So in this video, I want to review fractional exponents and how they're related to square roots or cube roots or fourth roots. For example, square root of x is equivalent to x to the power of half. So let's see why that is. We know that if we multiply square root of a number with itself, we get x. Now the question is, if we were to replace this with some exponent, what does this need to be so that we get x, or the original number, to the power of 1? And if I call that exponent a, then we know that when we multiply with the same bases, I can add them. So this is a plus a, which is not 2, but x to the 2a. And for these two to be equal, this expression to be equal, 2a must be equal to 1, or a is half. So essentially this missing piece needs to be half. Or another way you can, also easier once you know the answer, is that this is indeed true. X to the half times x to the half is 1, because half plus half is 1. So square root of x is equivalent to x to the power of half. And so is the case with the cube root. So when we look at cube root of x, and generally the cube roots or the fourth roots are written in this way, where you have this square root symbol and then you put the number here. In case of square root, I mean technically it should be this, but we just write it as square root of x. So if you don't see any number, that's to be assumed as square root. Otherwise, if you see a number here, this would be the fourth root, third root. So the third root is that number multiplied with itself 3 times. That would give you x itself. So again, we see that it has to be to the power of third, because when we add the exponents, a third plus a third plus a third, that would be equal to 1. Similarly, the fourth power of x is x to the 1/4. So you will see problems that either might have this in the statement or that, and you have to recognize that those are the fourth roots. In terms of some common examples, 27 to the 1/3, they're asking for cube root of 27, which we know is 3, because 3 cubed is 27. And another one that's common, 116 to the power of 1/4 is 2. 2 to the 4th is 16. 64 to the 1/3 is 4. So I'm just listing some of the common ones that are likely to show up. So in terms of the general rule for these roots and how it applies, we'll look at this general expression. A is some base and to the power m over n. So we can write this as a to the m to the power of 1/n, and this is the nth root. So in other words, we can write it like this. We can also write this as a to the 1 over n times m, and this is same as the nth root of a and then raising it to the power of m. So they're both equivalent, and you might have to manipulate this. It might be a little bit harder to see it here in this example with all the variables, so I'll do it within a number. Might be easier to see. So 27 to the power of 2/3. So we can rewrite this as 27 to the 1/3 and then squared. And 27 to the 1/3 is the cube root of 27. And that is 3. And we just have to square it, so that's 9. Now, as far as a question, this is a good example of a question. You're given that x to the power of 2/3 is 9. What is x equal to? So again, we can raise both sides to the power of 3 over 2. And doing so is going to just make this x to the 1, because if you multiply these two numbers, that's 1. And so we have x is equal to 9 to the power of 3 over 2. Now we have to simplify this. Now there are two ways we can do this. We can either write this as 9 cubed and then square root, or to the power of half, or square root of 9 then cube. You'll find that this is more work. I mean, they will eventually give you the same answer, but 9 cubed is a large number, whereas finding 9 to the half or square root of 9 is easier. Square root of 9 is 3, and then we cube this, we get 27. So that completes this lesson on fractional exponents.